have only two options. How is this video going to turn out for you? You will either fall asleep or you will get extremely smart on the topic of space. So close your eyes and listen. Space is not completely empty. Even interstellar space typically contains a few atoms of per cubic centimeter. Few atoms in cubic centimeter even in the vacuum, which doesn't make it really a vacuum, does it? The sun holds about 99.86% of the solar system's mass. Most of the solar system is just the sun, that beautiful star that gives us heat. A day on Venus, one rotation, is longer than its year, one orbit. A day on Venus, one rotation, is longer than its year, one orbit. Must be crazy on Venus. Mercury has water ice in permanently shadowed craters near its poles. There is water on Mercury, but we don't really want to go there. Did we even land it on Mercury? If you know, let me know down in the comments. Jupiter's great red spot is a storm larger than Earth that has persisted for centuries. Jupiter's red spot. We have to deal with red spots. I tried to deal with them since my puberty, and it didn't work like in Jupiter's case. Saturn is less dense than water. Its average density is below 1 gram per centimeter squared. Or in freedom units, it's, 1 feather over 3 boots or something, I don't know. Saturn is less dense than water. Uranus rotates on its side with an axial tilt of about 98 degrees. So Uranus doesn't spin like our Earth, but it spins like a ball, which is interesting how it managed to gain this momentum. Neptune was predicted mathematically before it was observed based on Uranus's orbit. Neptune was predicted mathematically before it was observed based on Uranus's orbit. The moon with capital M, the one we landed on, is slowly moving away from Earth, yes, about a few centimeters per year. The moon is actually not falling down, but moving away. It has some sort of energy still, and moves away. So one day we will say, bye bye moon. It will be like probably sun will explode sooner. Tidal friction from the moon is gradually slowing Earth's rotation. Days get longer over time, because when there is a moon, it has so much mass that the gravity pulls the water in, like sucks it in, and that makes the tidal waves. Very important biological process. Many organisms have it as their own clocks. The Milky Way is on a collision course with the Andromeda galaxy. They will merge in several billion years. That's not gonna be pretty, but it's gonna happen. It's gonna happen, and we are not going to do anything about that. The cosmic, I will bend it like that. The cosmic microwave background is the afterglow of the early universe, filling space in all directions. Cosmic microwave background. They can see like into the past thanks to this. The observable universe is limited not by what exists, but by what light has time to reach us. Yes. So the observable universe is so far as the light had ability to actually come to us. Because something can be that like we see it expanding, maybe we just see farther away because the light, it travels very fast, but not that fast. The International Space Station orbits Earth roughly every 90 minutes. It's a fast boy. The International Space Station orbits Earth roughly every 90 minutes, hour and a half. Astronauts grow slightly taller in space because their spines decompress in microgravity. I'm going to put on my dating profile that I'm 6 feet or 183 centimeters, but in microgravity, and I'm just not going to say it in that profile. It's our little secret, okay? Okay, can you hold the secret? Perfect. A light year is a distance, not a time. Very important. About 9.46 trillion kilometers. So the way my grandparents used to go to school in heavy snow and back. The sun's light takes about 8 minutes to reach Earth. So when the sun stops working, in 8 minutes there will be darkness. We will notice in 8 minutes. If sun disappeared, the gravity also works in 8 minutes. The sun's core temperature is around 15 million degrees Celsius, enabling nuclear fusion. Yes, what we really want. The heliosphere is a vast bubble of solar wind that extends far beyond Pluto's orbit. The heliosphere is a vast bubble of solar wind. Earth's magnetosphere helps shield us from charged particles in the solar wind. Yes, it's very important that we have that. And I was watching, what was that, Vsauce, maybe? They were discussing how actually it formed. It probably formed because of the sun, and it gave the magnetic. You need something to magnetize the core and stuff, and it still is active because the magma and the iron inside our Earth is still shifting, but once in a while the magnetic poles actually flip. Not like instantly, but over time, and that's interesting. And we know it happened, and it should happen sometime soon. Jupiter's magnetic field is the strongest of any planet in the solar system. Io, a moon of Jupiter, is the most volcanically active world known. There is a ton of volcanoes. It's almost like in the nether. Europa likely has a global subsurface ocean beneath its icy crust. Europa, the moon. Titan, Saturn's moon, has rivers and lakes made of liquid methane and ethane. I know people that would go there if it was not ethane but ethanol. I know them personally. Enceladus, Saturn's moon, sprays water-rich gases from cracks near its south pole. Enceladus sprays water-rich gases from cracks near its south pole. Mars has the largest volcano in the solar system, Olympus Mons. Mars has the largest volcano in the solar system, Olympus Mons. Mars has an enormous canyon system, Valles Marineris. Enormous canyon system that could be useful during the colonization, because you want to probably dig inside, you don't want to be on the surface, you don't have atmosphere, you have rapid shifts in temperature. The asteroid belt is a mostly empty space. Spacecraft can pass through it easily. So even though there is lots of asteroids that are floating in the circle, spacecraft, there is lots of holes, let's say Sherlock holes. Comets develop tails when sunlight and solar wind heat and push material off their surfaces. Yeah, they make like this tail and they fly through the space, and that debris is pulled by the gravity behind them. And it's very nice to see. If you've ever seen the comet, I just always remember when I was a young boy and I used to go on a haystack. You flip those round haystacks and put a towel or something over it and just lay it down and watch the stars. I should make video like that one day. That would be nice. We can go star watching together. What do you think? A comet's ion tail points directly away from the sun due to the solar wind. Oh, yeah. Okay. The Kuiper belt beyond Neptune contains many icy bodies, including dwarf planets. The Kuiper belt, Kuiper, Kuiper. Pluto and Charon orbit a point in space between them, a barycenter that lies outside Pluto. Pluto and Charon orbit a point in space between them, a barycenter. Interesting. Many meteor showers happen when Earth crosses a comet's debris stream, like Perseids. I always used to watch these. Most meteors are tiny, often grain-sized, yet they can create bright streaks as they burn up. Yeah, this is something that always fascinated me. That we have this protective shield, the atmosphere, and it burns down those little fast things. Space has a background temperature of about 2.7 Kelvin, so not absolute zero, set largely by the cosmic microwave background, so it's not that cold in the space. Black holes can form when massive stars collapse at the end of their lives. A black hole's event horizon is the point beyond which light cannot escape, and imagine you get sucked into the black hole. They are now thinking in CERN about making some small black holes just to test it. I don't think that's a good idea, but what do I know? I just whisper into the microphone. Neutron stars are so dense that a teaspoon of their material would weigh billions of tons on Earth. Very heavy, very good for lifting. That would be, you could make like small, very tiny weights, and you can just put them, and that would be like 10 kilos. That would be like atoms, more or less. Pulsars are rapidly rotating neutron stars that sweep beams of radiation like cosmic lighthouses. Pulsar stars, yeah. Magnetars are neutron stars with ultra-strong magnetic fields that can disrupt electronics at huge distances, in theory, if close enough, like EMPs, for example. Magnetars. The Milky Way is barred spiral galaxy. Yeah, Milky Way is like spiral. Our solar system orbits the Milky Way's center roughly once every 225 to 250 million years. Our solar system orbits Milky Way center, so it's not that fast, but in the cosmic sense it's probably very fast, I would say. A center of the Milky Way hosts a supermassive black hole called Sagittarius A star. Sagittarius, big, massive black hole in the center of Milky Way. Star colors indicate temperature. Blue stars are hotter than red stars. Blue stars are hotter than red stars. Yes, because blue is more on the spectrum. You know, you have infrared up to ultraviolet. So if you think about rainbow, the red is at the bottom. Red is heat, and ultraviolet is like UV. The most common type of star in the Milky Way is the red dwarf, of course, because those are those that already spend all their energy. The Sun is a G-type main sequence star, yellow dwarf. The Sun is yellow dwarf, but it works very well. I have to say, good job, Sun. I like you. Elements heavier than helium are largely forged in stars and supernova explosions. Elements heavier than helium, yes. For example, gold. Almost all gold and iron and heavy metals are asteroids that fell into the Earth. I know that we know about some comets that it's like pure gold, like massive amount of pure gold. Gold and many other heavy elements are strongly associated with extreme events like neutron star mergers. Yes. The Orion Nebula is a stellar nursery where new stars are forming. That's cute. That's very cute. Orion Nebula. It's a nursery and they are singing a little songs to the small stars. Probably not. A nebula can be star-forming gas, the remains of a dead star, or both, depending on the type. Supernovae can briefly outshine entire galaxies. Supernovae. The Crab Nebula is the remnant of supernova observed in 1054 CE. Yeah, that's like, can you imagine living not even like 300 years ago and you see like eclipse, solar eclipse, and like, what the hell? Sun disappeared. So this was always in every scribe written like this happened, this was a huge thing, like we were sitting outside and now dark. So there was a supernova, and of course you see supernova, that's insane event in the stars. White dwarfs are basically stars where like their television, like you just, like I used to do, I sit down and watch the stars. They used to do that all the time because there was nothing else to do. White dwarfs are Earth-sized stellar remnants supported by electron degeneracy. White dwarfs are Earth-sized stellar remnants supported by electron degeneracy pressure. I'm not going to comment to that. If a white dwarf in a binary system gains too much mass, it can trigger a type E supernova. Type 1A, this is probably 1A. Type 1A supernovae are used as standard candles to measure cosmic distances. Type 1A, EA, it's IA, it's type IA supernovae are used as standard candles to measure cosmic distances. Interesting. The universe is expanding and distant galaxies generally recede from us. No, they are running away. Oh no. Hubble's law links a galaxy's recessional speed to its distance on large scales. Hubble's law. Redshift, that's almost like a red sapphire, is the stretching of light to longer wavelengths. Yes. Often due to cosmic expansion, like you have light and the universe expands, so the light stretches and it becomes red, as we said, lower energy red. The James Webb Space Telescope observes mainly in infrared, ideal for seeing through dust and studying very distant galaxies. Infrared astronomy can reveal cool objects like brown dwarfs and protoplanetary disks. There's always something happening in the universe. Brown dwarfs are failed stars, like me, that aren't massive enough to sustain long-term hydrogen fusion because you need a lot of pressure. Sun is very under a lot of pressure. And if you are not big enough, then it just doesn't work. The nearest star system to the Sun is Alpha Centauri, over 4 light years away. Just 4 light years away. We can get there like in, I don't know, million years. Proxima Centauri. The closest star to the Sun is a red dwarf. Proxima Centauri is a red dwarf. The habitable zone is the range where liquid water could exist on a planet's surface under the right conditions. The habitable zone. We are living in the habitable zone. Many exoplanets discovered are hot Jupiters, gas giants orbiting extremely close to their stars. Many exoplanets, they fly too close. Icarus don't fly too close to the Sun, and they do that. But they are hot Jupiters. One common exoplanet detection method is the transit method. A planet slightly dims starlight as it crosses. Exoplanet detection method is the transit method. Yes, planet slightly dims starlight. So you look at the star and now you see, oh, it dimmed a little bit because the planet went over and went over, which happens with us too, with the moon. Another is the radial velocity method. A star wobbles due to a planet's gravity shifting its spectral lines. That's good too, because the Sun affects us, but we affect the Sun too. everything affects everything. Gravitational microlensing can detect planets by how they bend and magnify background starlight. Gravitational microlensing. We have so many methods. The first confirmed exoplanets were found around a pulsar in the early 1990s. We found first exoplanets in 1990s. The solar system planets formed from a rotating disk of gas and dust called the solar nebula. Planetary rings can be made of countless particles, from dust to boulder-sized chunks. If you like this video, don't forget to like it and subscribe, and maybe share it with somebody who likes space and sleeping too. I think many people like sleeping. Sleeping is very popular. Saturn's rings are mostly iced water. The Roche limit is the distance where tidal forces can tear apart a body held together mainly by gravity. Some ring systems likely come from shattered moons or disrupted comets. Shattered moon or disrupted comets. The Oort cloud is a hypothesized distant reservoir of icy bodies that may feed long period comets. Oort cloud. The solar wind can create auroras when charged particles collide with a planet's atmosphere. Auroras. Nice. Auroras occur not only on Earth, but also on Jupiter, Saturn, and another magnetized planets. Yes, that's important. They have to be magnetized. Some are not magnetized. Jupiter's auroras are powered not just by the solar wind, but also by particles from Io, the moon of the Jupiter. The solar eclipse happens when the moon blocks the sun from Earth's view, but you probably knew that because you are extremely smart. Total solar eclipses are possible because the sun is about 400 times larger than the moon, but also about 400 times farther away. That's a coincidence, isn't it? I think not. No, it's probably not, because that's why it's stabilized. The moon is tightly locked to Earth, so we always see roughly the same face. We are tightly locked, yes. The far side of the moon isn't permanently dark. It gets sunlight just like the near side. Lunar Maria. The dark basalt plains formed by ancient volcanic eruptions. Lunar Maria are dark basalt, like in Minecraft, plains formed by ancient volcanic eruptions. Earth's atmosphere burns up mostly incoming space debris. Without it, impacts would be far more common. Yes, thanks for our atmosphere. The Kármán line, about 100 kilometers altitude, is often used as a boundary of space. Though definitions vary, but 100 kilometers, when you shoot like this science-based rocket into 100 kilometers, you went into the outer space. Microgravity in orbit happens because spacecraft and astronauts are in continuous free fall around Earth. When you're in orbit, you are basically in free fall all the time. First humans on the moon were Apollo 11 astronauts in 1969, and somebody will say it was faked in Hollywood, but there was many landings. The Apollo missions left retroreflectors on the moon that allow precise laser distance measurements. Yes, we have still there are the retroreflectors. Voyager 1 and Voyager 2 have traveled beyond the heliopause into interstellar space. The pale blue dot photo was taken by Voyager 1 from billions of kilometers away. The pale blue dot photo was taken by Voyager 1 from billions of kilometers away. The speed needed to escape the Earth's gravity from the surface, ignoring air resistance, is about 11.2 kilometers per second. So the speed to escape Earth's gravity is about 11.2 kilometers per second. That's very fast. Rockets work in space because they push on their own exhaust. Yes, they don't need air to push against. Yeah, they push on their own exhaust. That was very important discovery too. In vacuum, there is no sound transmission because sound needs a medium. Yeah, that's at least one thing they don't have to worry about that much. Spacecraft use radiators to dump heat since they can't cool by air convection. Spacecraft use radiators to dump heat since they can't cool by air convection. The Hubble Space Telescope has produced ultra-deep images revealing thousands of galaxies in tiny patches of sky. The Hubble Space Telescope has produced ultra-deep images revealing thousands of galaxies in tiny patches of sky. The Goldilocks problem in space engineering includes balancing mass, power, and reliability. The Goldilocks problem. Balancing mass, power, and reliability, because you want to be light, powerful, but still reliable. A geostationary satellite orbits once per day and stays above the same point on Earth's equator. Geostationary satellites, they stay on the same point of they are synced. It's incredible how we managed to do that. Low Earth orbit, LEO, typically ranges from roughly 160 kilometers to 2000 kilometers altitude. The Van Allen belts are regions of trapped charged particles around Earth. The Van Allen belts are regions of trapped charged particles around Earth. So that was 100 questions. Now another. Hopefully you are feeling good. Hopefully you learned something, or you are sleeping, which would be even better because that's what you should do. The sun will eventually expand into a red giant and later shed its outer layers, leaving a white dwarf, and we will burn. A planetary nebula is the glowing gas expelled by a dying sun-like star. Despite the name, it's not a planet. The Andromeda galaxy is our nearest large galactic neighbor. Andromeda galaxy. We need to have some good neighboring relations. Galaxies can be spiral, elliptical, or irregular. often shaped by collisions and mergers. The universe's large-scale structure forms a cosmic web of filaments and voids. Dark matter is inferred from gravity like galaxy rotation curves, but does not emit light. Dark matter. Dark energy is the name given to the unknown cause of the universe's accelerating expansion. We don't know what it causes yet. Gravitational waves are ripples in space-time, predicted by Einstein and directly detected by LIGO. What's LIGO? LIGO's first detection, 2015, came from merging black holes. Neutron star mergers can produce both gravitational waves and brilliant electromagnetic kilonova events. The sun's corona is much hotter than its surface. One of solar physics classic puzzles. Sunspots are cooler, magnetically active regions on the sun's surface. They are not mathematically active, they are magnetically active. The sun's activity follows an approximately 11-year cycle. Cycling. Solar flares are sudden release of magnetic energy that can affect satellites and radio communications. Coronal mass ejections, CMEs, are massive eruptions of solar plasma that can drive geomagnetic storms. Earth's seasons are caused mainly by axial tilt, not by distance to the sun. Yes. Earth is actually closest to the sun in early January. Perihelion, it's called perihelion. Mars has seasons too, and its axial tilt is similar to Earth's. Some asteroids are rubble piles loosely held together by gravity. Some asteroids are rubble piles. NASA's DART mission demonstrated asteroid deflections by impacting the asteroid Moonlet. Dimorphos is moonlet. It's just a small moonlet that, like, if someone calls you manlet. The sun's surface temperature is about 5,500 degrees Celsius, far cooler than its core. Far cooler, that was 15,000. The sun produces energy by fusing hydrogen into helium via the proton-proton chain. They merge the protons. Neutrinos from the sun pass through Earth constantly. Trillions go through you every second. You are just neutrino blasting. Anyway, I started blasting. That's the sun. The solar constant is the average solar energy received per square meter at Earth's distance, top of atmosphere. The Earth-Moon system stabilizes Earth's axial tilt, helping long-term climate stability. Mars's thin atmosphere is mostly carbon dioxide. Venus's atmosphere is also mostly carbon dioxide, but extremely dense and hot due to runaway greenhouse effects. Venus's surface pressure is about 90 times Earth's, like being 1 kilometer underwater. That's a lot of pressure. That would make my muscles grow so big. Jupiter and Saturn have no solid surfaces you could stand on. They transition from gas to liquid under pressure. Jupiter emits more heat than it receives from the sun due to internal processes. It's bubbling there. It's making a lot of heat. Saturn's moon, Iapetus, has a striking two-tone coloration. Dark leading hemisphere, bright trailing. Beautiful. Some moons may have subsurface oceans kept warm by tidal heating, like the water or the liquid shifts. Tidal heating happens when gravity flexes a body repeatedly, generating internal friction and heat. Exactly. The snow line in a young solar system is where it's cold enough for water ice to condense, aiding giant planet formation. The snow line is where it's cold enough for water ice to condense. The asteroid Vesta is large enough to be nearly spherical and shows evidence of differentiation, core, mantle, crust-like layers. The asteroid Vesta. Ceres is a dwarf planet in the asteroid belt and shows signs of past and possibly present briny activity. Okay. Space telescopes avoid atmospheric distortion and absorption that affect ground-based observations. Yes. Adaptive optics on ground telescopes can partially correct atmospheric blur in real life. Adaptive optics. We have so many cool stuff nowadays. Radio telescopes can observe through clouds and dust that block visible light. They can send radio waves. The Event Horizon Telescope produces the first image of black hole shadow M87 star using Earth-sized interferometry. A parsec is about 3.26 light years and comes from parallax geometry. Parsec. Stellar parallax is the apparent shift of a nearby star against distant background stars as Earth orbits the Sun. That's stellar parallax. The Gaia spacecraft has mapped the positions and motions of over 1 billion stars in the Milky Way. The Gaia spacecraft. The Gaia is it the Earth? Let me know down in the comments. That's the goddess of Earth, Gaia. Yeah. The Doppler effect shifts light to blue when an object moves towards us and to red when it moves away. So it works on the light too, but we just cannot see it on the Earth because the distances are so small. But in the space you can see it because the distances are massive. And you know what else is massive? No, that's like 2004 meme. Spectroscopy lets scientists identify elements in stars and planets by their unique spectral fingerprints. Metallicity in astronomy means elements heavier than helium. Older stars generally have lower metallicity. The first stars likely formed from mostly hydrogen and helium before heavier elements existed. Yes, that makes sense. Quasars are extremely luminous, active galactic nuclei powered by matter falling into supermassive black holes. Some quasars are visible from billions of light years away, acting as beacons from the early universe. The strongest known explosions include gamma ray bursts, often linked to massive star collapse or compact object mergers. Gamma ray bursts can outshine galaxies briefly in high energy light. Yes, they are very shiny. Cosmic rays are high energy particles, mostly protons, that strike Earth from space. And you can see them when I was in Dukovany atomic nuclear facility. They have this, I don't know how it's called, that gas chamber where you can see particles and you can sometimes see the space radiation like dipping through that. It basically like condenses the, I don't know what's exactly is inside the chamber, but it condenses and shows you the path where it flew. Earth's atmosphere protects us by absorbing much of the harmful high-energy radiation from space. The ISS has a thin residual atmosphere at its altitude, causing drag. It needs periodic reboosts. Yeah, it's sometimes slows. So, spacecraft often use gravity assists, stealing a tiny bit of orbital energy from planets to gain speed. If you played Kerbal Space Program, you know how it works. A Lagrange point is a gravitational balance region where spacecraft can maintain position with minimal fuel. The James Webb Space Telescope operates near the Sun-Earth L2 Lagrange point. Meteorites are classified as stony iron or stony iron, depending on composition. Interesting, I didn't know that. Some meteorites come from the Moon and Mars, blasted off by impact and later landing on Earth. So we have some moonstones there. Earth's oldest known minerals, zircons, suggest a liquid water existed very early in Earth's history. Yes, in zircon sometimes there is a water inside and they can see it and analyze it. It's like trapped inside. Space dust is real and widespread. It can redden and dim starlight passing through it. The interstellar medium includes gas, dust, and cosmic rays between stars. The Sun is moving through a region of low-density interstellar gas called the local interstellar cloud. It's in the cloud. Everything is in the cloud now. The solar system is inside a larger region called the local bubble. Thought to be carved by ancient supernovae. A supernova near Earth could affect the atmosphere, but supernovae close enough to be dangerous are rare but possible. The Sun's mass loss via solar wind is tiny compared to its total mass, but it's continuous. It's slowly getting depleted. The Sun will remain on the main sequence for a total of roughly 10 billion years. So, we have time. The Moon likely formed after a giant impact between early Earth and Mars-sized body. The leading theory explains the moon's small iron core and Earth-Moon composition similarities. Earth's oceans may have multiple origins, including water delivered by hydrated minerals and impacts. Everything was just blasting the Earth at the start. The faint young sun paradox refers to evidence of early liquid water despite the sun being dimmer long time ago. Mars shows strong evidence of ancient rivers, lakes, and minerals that form in water. The largest known impact structure on Earth is difficult to identify because erosion and plate tectonics erase evidence. The Chicxulub impact 66 million years ago is strongly linked to the dinosaur mass extinction. Yes, the massive crater. It's Chicxulub. The term planet is defined by the IAU. Pluto is classified as a dwarf planet because it hasn't cleared its orbital neighborhood. It hasn't cleared, so it still hasn't cleared the orbital neighborhood. Or no, it doesn't clear it like everything around, yeah. Dwarf planets include Pluto, Eris, Haumea, Makemake, and Ceres. Eris is slightly smaller than Pluto, but more massive. Eris is slightly smaller than Pluto, but more massive. The Sun's spectrum has dark absorption lines, Fraunhofer lines, caused by elements absorbing specific wavelengths. The Sun's spectrum has dark absorption lines, Fraunhofer lines, caused by elements absorbing specific wavelengths. The green flash at sunset is an atmospheric effect on Earth, not a space phenomenon, but it's tied to optics and refractions. The Earth's atmosphere glows faintly at night, airglow, visible from space as a thin, luminous layer. And the last 20 questions, or not questions, facts, interesting facts. The term astronaut literally means star sailor. The first artificial satellite was Sputnik 1 in 1957. The first animal in orbit was a dog, Laika, aboard Sputnik 2, 1957. Yeah. The first reusable orbital spacecraft was the Space Shuttle, first flight 1981. Re-entry heating is mostly from atmospheric compression in front of spacecraft, not friction alone, so atmospheric compression. A space suit is personalized spacecraft, pressure, oxygen, cooling and radiation protection limited, all in one. Spacewalk gloves are among the hardest parts of a spacesuit design because hands need dexterity under pressure. Yeah, those are like massive gloves. Many space missions use RTGs, radioisotope thermoelectric generators, for power far from the sun. Pluto receives so little sunlight that noon there is like deep twilight on Earth. On the moon, footprints can last for millions of years because there's no wind or rain to erase them, so they should still be there. Lunar dust is sharp and abrasive because it hasn't been weathered smoothed by water or atmosphere, so it's not like in Sahara, for example. The terminator line on a planet or moon is the boundary between day and night, the day-mean terminator. The blue marble photos of Earth helped shift public perception of Earth as a fragile world. Earth is the densest planet in the solar system. The sun's gravity is so dominant that even Jupiter is only about 1,000th of the sun's mass. The sun is massive. So Jupiter is 1,000th of the sun mass. That's pretty big. The largest volcano in the solar system, Olympus Mons, is a shield volcano built by many low viscosity lava flows. So it's just built. The largest known canyon system in the solar system, Valles Marineris, stretches thousands of kilometers. Some of the brightest objects in the night sky, like Venus, are bright mainly because they reflect sunlight well and are close. The zodiacal light is a faint glow in the sky caused by sunlight scattering off interplanetary dust. And the last fact, even empty space has structure, magnetic fields, radiation, dust, and particles shape that happens between the stars. So that's it. You should be either sleeping or you should be very smart by now. And I hope you liked the video. If you did, let me know down in the comments what would you like to see next, and you can click on another video to watch it, something that you will find interesting. I have many videos, you can check them all, you can watch them all, and I would really appreciate that. So anyway, and last time, if you really like the channel, consider clicking the join button and becoming a member. Giving some money every month really helps to keep the lights on. So, last time, thank you for watching, and I will see you next time.